The situation involves kitchen ground fault circuit interrupters, or GFCIs, tripping when the jets in an outdoor hot tub are turned on. The home has a 400 amp service with two 200 amp panels in the basement. The hot tub is located about 50 feet away in the deck and is fed from one of the panels to a spot disconnect at the tub. The kitchen GFCIs are fed from the other panel. Everything functions normally in the kitchen until the hot tub jets are activated. Even after unplugging all appliances on the kitchen circuits, the GFCIs still trip when the hot tub jets are running. Several possible causes could be responsible. Firstly, a loose or faulty neutral connection can cause unbalanced current flow, leading to GFCI tripping. Secondly, a ground fault somewhere in the circuit, such as a damaged wire, can also trip GFCIs. Thirdly, exceeding the load capacity of one or both circuits can overload the GFCIs, causing them to trip. Fourthly, a malfunctioning or damaged hot tub could be causing an electrical fault that is tripping the GFCIs. Fifthly, the electromagnetic field generated by the hot tub jets can induce current into nearby wires, causing GFCIs to trip. Sixthly, the GFCIs themselves could be faulty and tripping unnecessarily. To troubleshoot this issue, consider the following steps. 1. Verify all electrical connections, ensuring that connections including the hot tub disconnect, neutral connections, and ground connections are tight and secure. 2. Temporarily disconnect the hot tub from the electrical system to see if that resolves the issue. 3. Use a voltage meter to check for voltage between the ground and neutral wires on the affected circuits. If voltage is present, a ground fault may exist. 4. Calculate the total load on the affected circuits. If it exceeds the circuit rating, the GFCIs may be tripping due to overload. 5. If isolating the hot tub circuit does not solve the problem, have the hot tub thoroughly inspected by a qualified electrician. 6. If no other cause can be identified, replace the affected GFCIs to eliminate the possibility of faulty devices. There are some additional considerations to keep in mind. If the hot tub was recently added, it may have been improperly installed or connected. The length of the wire run to the hot tub can increase resistance and voltage drop, potentially affecting the operation of GFCIs. Given the complexity and potential safety hazards involved, it is always advisable to consult with a licensed electrician to diagnose and resolve the issue safely and effectively. A neutral fault is a common cause of GFCI tripping. The neutral wire is supposed to carry the return current from the circuit back to the electrical panel. If the neutral connection is loose, corroded, or otherwise compromised, it can create an imbalance in the current flow. GFCIs are designed to detect even small imbalances between the hot and neutral wires, typically around 5 mA. When the current flowing through the hot wire differs from the current returning through the neutral wire by this amount, the GFCI trips, interrupting the circuit. Checking for a neutral fault involves visually inspecting the neutral connections at the electrical panel, at the GFCI outlets, and at any junction boxes along the circuit. Look for signs of loose wires, corrosion, or damage. Use a screwdriver to tighten any loose connections. If you find any corroded wires, clean them with a wire brush and apply an antioxidant compound before retightening the connections. A ground fault occurs when current leaks from a hot wire to a grounded surface. This can happen if the insulation on a wire is damaged or if there is moisture present in the circuit. GFCIs are designed to detect ground faults and trip the circuit to prevent electrical shock. To check for ground faults, you can use a multimeter to measure the voltage between the hot wire and a grounded surface, such as a metal pipe or the grounding wire in the electrical panel. If you measure any voltage, it indicates a ground fault. You can also use a ground fault tester, which is a specialized device that simulates a ground fault and tests the GFCI's ability to trip. An overload occurs when the total amount of current being drawn on a circuit exceeds the circuit's capacity. Each circuit is protected by a circuit breaker or fuse that is designed to trip when the circuit is overloaded. However, GFCIs can also trip due to overloads, especially if the overload is sudden or severe. To check for overloads, calculate the total load on the affected circuits by adding up the wattage of all the appliances and devices that are plugged into those circuits. Then compare that total to the circuit's rating, which is typically 15 amps or 20 amps for standard household circuit. If the total load exceeds the circuit rating, you need to reduce the load by unplugging some appliances or devices. Induction can occur when a strong electromagnetic field induces current into nearby wires. This is more likely to happen when the wires are run close to each other and when the electromagnetic field is strong, such as from a motor or transformer. The hot tub jets generate a strong electromagnetic field when they are running. If the wires for the kitchen GFCIs are run close to the wires for a hot tub, the electromagnetic field from the hot tub jets can induce current into the kitchen circuits, causing the GFCIs to trip. To mitigate induction, try to separate the wires for the kitchen GFCIs from the wires for the hot tub as much as possible. You can also shield the wires by running them in metal conduit. It is also possible that the GFCIs themselves are faulty. GFCIs can fail over time due to age, wear, or electrical surges. If you have ruled out all other possible causes, the next step is to replace the GFCIs. When replacing GFCIs, be sure to use the correct type of GFCI for the application. There are two main types of GFCIs. One is standard GFCIs, which are used for general purpose circuits, and the other is appliance GFCIs, which are used for appliances such as dishwashers and washing machines. It is also important to install the GFCIs correctly. Be sure to follow the manufacturer's instructions carefully. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install the GFCIs. Additional things to consider include the hot tub may have been improperly installed or connected. The length of the wire run to the hot tub can increase resistance and voltage drop, potentially affecting the operation of GFCIs. The longer the wire run, the more resistance there is in the circuit. This resistance can cause a voltage drop, which can affect the performance of the GFCIs. To mitigate voltage drop, use a larger gauge wire for the hot tub circuit. Also, make sure that the hot tub is properly grounded. A proper ground provides a path for fault current to flow back to the electrical panel, which helps to protect against electrical shock. If you're uncomfortable performing the following tasks, it's best to consult a qualified electrician. Using a multimeter to check for voltage between the ground and neutral wires on the affected circuits. Calculating the total load on the affected circuits. Inspecting the hot tub's wiring and components. Replacing GFCIs. These tasks can be dangerous if not performed correctly. If you're unsure how to do any of these tasks, it's best to hire a qualified electrician. A qualified electrician will have the knowledge and experience to diagnose and repair the problem safely and effectively. The electrician can also ensure that the electrical system is up to code and that all safety precautions are taken. A multimeter is an essential tool for troubleshooting electrical problems. It can be used to measure voltage, current, and resistance. To use a multimeter to check for voltage, set the multimeter to the voltage setting. Then touch the probes to the 2 points you want to measure the voltage between. The multimeter will display the voltage reading. To use a multimeter to check for current, set the multimeter to the current setting. Then break the circuit and insert the probes in series with the circuit. The multimeter will display the current reading. To use a multimeter to check for resistance, set the multimeter to the resistance setting. Then touch the probes to the 2 points you want to measure the resistance between. The multimeter will display the resistance reading. When using a multimeter, be sure to follow the manufacturer's instructions carefully. Also, be careful not to touch any exposed wires or terminals. Electrical shock can be fatal. Calculating the total load on a circuit is an important step in troubleshooting electrical problems. If the total load on a circuit exceeds the circuit's capacity, the circuit breaker or fuse will trip. This can cause appliances and devices to stop working. To calculate the total load on a circuit, add up the wattage of all the appliances and devices that are plugged into that circuit. The wattage of an appliance or device is typically listed on a label on the appliance or device. Once you have calculated the total wattage, divide that number by the voltage of the circuit, which is typically 120 volts in the United States. The result is the total current draw on the circuit. If the total current draw exceeds the circuit's capacity, you need to reduce the load by unplugging some appliances or devices. Inspecting the hot tub's wiring and components can help to identify any potential problems. Look for signs of damaged wires, loose connections, or corroded terminals. Also, check the hot tub's components for any signs of damage or wear. If you find any problems, have them repaired by a qualified electrician. Replacing GFCIs is a relatively simple task, but it is important to do it correctly. Be sure to turn off the power to the circuit before replacing the GFCI. Then remove the old GFCI and install the new GFCI, following the manufacturer's instructions carefully. Once you have installed the new GFCI, turn the power back on and test the GFCI to make sure it is working properly. Remember, electrical work can be dangerous. If you are not comfortable performing these tasks, it is best to hire a qualified electrician. They can diagnose and repair the problem safely and effectively.